As soon as you stand up, as you walk into another room, and then you stand there, empty. You don't remember why you came in. This happened yesterday. This is happening today. You think it's a sign of a brain slowing down? Is that true? No, it's a mechanism. A mechanism older than the room you're standing in.
In 2011, a psychologist named Gabriel Radvansky wanted to know why this happens. He worked at the University of Notre Dame. He didn't just ask whether people forget things, he built an experiment to prove it. Participants moved through a virtual space on a computer. They carried objects with them, an apple, a book. Sometimes they walked through a doorway into another room. Sometimes they walked the same distance, but inside one large room with no door. What was the result?
When there was a doorway, their memory of the object got noticeably worse, not because of distance, not because time had passed, just because of the doorway. Radvansky repeated this experiment in real life, not only in the virtual world. The results stayed the same. Your body doesn't need a real doorway to be affected, but a real doorway makes the effect even stronger. Around the same time, another scientist was studying a bigger question. His name was Jeffrey Zacks. He worked at Washington University in St. Louis. Zacks wanted to know, how does your brain decide when one moment ends and another begins? He developed a theory. That theory is called Event Segmentation Theory. Put simply, your brain doesn't record life as one continuous video. It cuts life into separate segments, the way a film editor cuts scenes.
Why does your brain do this? Because if it remembered every single second with equal detail, the amount of information would be overwhelming. Your brain needs to find natural cut points. Those points are called event boundaries. A doorway is one of the strongest boundaries your brain can recognize. When you're in the kitchen, your brain builds an event model for that kitchen. This model includes what you're doing, where things are around you, and your current goal. For example, I need to grab scissors. When you walk through the door into the living room, your brain treats this as a new event boundary. To free up processing space for the new context, your brain archives the old model. The information from the kitchen, including your goal of grabbing scissors, gets shifted from working memory into long-term storage.
What is working memory? It's the temporary part of your memory you use to hold information for a few seconds or minutes, like a whiteboard you write on and then erase. When you arrive in the living room, your intention to grab scissors doesn't disappear completely. It's just no longer loaded in your active memory. You have to spend mental energy to pull it back out of storage. That's the exact moment of blankness you feel. But this isn't just theory. Scientists have watched it happen live inside a human brain. A researcher named Ben-Yakov, working with Richard Henson, placed people inside an fMRI scanner, a machine that tracks blood flow in the brain to show which regions are active in real time. The participants simply watched a movie, nothing more. But every time the story crossed a boundary, a character left a room, a scene shifted, a moment ended, one structure deep in the brain lit up sharply. That structure is called the hippocampus. It's a small, curved region buried near the center of your brain, and it's central to how you form new memories. The spike wasn't random. The stronger the spike, the more likely that moment was later remembered. Your hippocampus isn't just sitting there. At every doorway, every boundary, every cut in your day, it fires, sealing the previous chapter shut and stamping it into long-term memory before moving on.
Now picture a specific scene. You're sitting in your office. You think of a great idea for the project you're working on. You stand up, planning to grab a notebook to write it down. You walk out of the office, down the hallway, into the bedroom where the notebook is. You stand there. You look around. Where did that idea go? You don't remember. You walk back to the office to try to think it through again. And strangely enough, the moment you step back in, the idea returns to your mind. Why does that happen? This is where the twist comes in. You might think the solution is to avoid every boundary, to stay in one space, never walk through a door, to keep memory continuous. But the truth is the opposite.
Another research team, building on the work of Radvansky and Zacks, tested this in a real learning environment. They had participants study a list of words. One group studied the entire list in one room. Another group studied half the list in one room, then walked through a door to study the rest in a different room. Which group remembered better? The group that walked through the door. They remembered significantly more words. Event boundaries don't just cause forgetting, they also help organize long-term memory better, as long as the amount of information between boundaries stays within the limits of working memory. A doorway isn't the enemy of your memory. It's a sorting tool. The problem isn't that the doorway exists. The problem is that sometimes a small intention, like grab the scissors, gets caught up in that sorting process before it makes it to the other side.
Think about what this means if you're studying for an exam. If you review every topic sitting in the exact same chair in the exact same room, your brain has no boundaries to sort that information into separate folders. Everything blurs into one long, undivided block. But if you study biology in your bedroom, then walk to the kitchen table to study history, then move to the library for math, each subject gets its own event model tagged to its own context. Your hippocampus treats each room as a separate chapter, and separate chapters are easier to pull back out one at a time when you need them during the exam. This is why pacing through different rooms while reviewing notes, something many students do without knowing why, actually works. It's not nervous energy, it's your brain building doorways on purpose.
Now look back at your modern life. You don't just walk through doorways at home. You end a phone call and the great idea you just had during the conversation disappears the moment you hang up. You leave an online meeting, close the video window, and forget the important thing you meant to do next. You step out of your car after a long drive and forget the item you meant to carry inside. Each of those is an event boundary. Each time your brain is doing exactly what it has done for hundreds of thousands of years, closing one chapter, opening another, and prioritizing the present over the recent past. Do you want to fight this? There's one way. If you forget something right after a boundary, go back to the old context. Walk back into the room you just left. Think back through the call. Replay the meeting in your mind. The old context still holds cues tied to that memory, and returning to it helps your brain reactivate the stored event model.
But there's something more important to remember here. Forgetting isn't a sign of a weak brain. It's a sign of a brain operating correctly. A brain constantly sorting, storing, and clearing space to process the present. Zacks, Radvansky, Ben-Yakov, and many other researchers spent years proving this isn't a flaw, it's the design. You stand up, you walk into another room, and this time when you stand there, empty, you don't see it as a failure of memory. You see it as living proof of a brain doing exactly what it was built to do, endlessly rewriting your story, one chapter at a time. Now, you know why it happens. The real question is, when was the last time it happened to you? Drop it in the comments. Someone else watching right now probably has the exact same story.